learn about fractions in elementary school. And then forever after, we have calculators in our hands. So I think many of us forget kind of just how these fractions behave. There's no shame in that. It's okay. We're going to talk about it right here. Just remind ourselves very quickly how fractions work, why they work the way they work, and how we can quickly manipulate them when we don't have a calculator in our hand. So we're going to start at the very beginning. That's a very good place to start. Okay, sorry, we have half of a pizza. We have 3/4 of a pizza. I'm going to add 1/2 plus 3/4. I think you would agree with me that that's kind of like adding apples and oranges. This bottom number tells me the size of the piece, if you will. I broke this pizza into halves. This bottom piece tells me I broke this pizza into 4 pieces. So the bottom number tells me how many pieces I divided my whole into. The top number tells me how many pieces I have. So obviously I can't say I have 4 equal size pieces because they're different sizes. So how much pizza do I have? I know that you're anticipating what I'm going to do here. What I can easily do is say, oh, well, let's just break this into 4ths. So instead of calling this 1/2, I can call this 2/4, and now I'm adding apples and apples, and I have 5/4, a little more, a 1/4 more than 1 whole pizza. All right. So, of course, kind of the way to do that is to get common denominators. And we can do that by doing something we're going to do over and over and over again. Multiply by a handy form of 1. Mathematicians love multiplying by 1 and adding 0. It's a very basic but very powerful tool, both of those. So I'm going to multiply this bottom by 2 and this top by 2. 1/2. Now I can call it 2/4. It has the same value, but I'm able to do my little procedure. Okay? I got a common denominator by multiplying by a handy form of 1. Good? Subtraction, same thing, right? Okay. So now, what if instead I wanted to do some multiplying? So, let's say I want to take 3/4 and multiply it by 1/2. Well, let's just think what that means. Another way to say that is I'm taking half of 3/4. Half of 3/4. Oh, well, I don't know. Maybe the way I would do it visually is I would just split each piece into halves, right? So let's see, I have 1, 2, 3, 4, 5, 6, so I'm going to have okay, looks like I have 3 pieces. How big is each piece? Well, if I had split the whole thing in to the same size, I think I just split it into 8ths, right? Okay, so obviously we're not going to always draw a picture. What did I do here? Sure, I multiplied together the numerators. 3 times 1 is 3. And I multiplied together the denominators. 4 times 2, which is 8. And that's it. Multiplying fractions, it's the numerators times the numerator divided by the denominator times the denominator. Okay? And I think it makes intuitive sense. The other thing, if I'm multiplying a fraction by or if I'm multiplying any number by a fraction that's between 0 and 1, you do want to have a smaller quantity. And I do, in fact, I'm left with a smaller quantity. All right, I have a new picture, 3/4, and I want to now divide 3/4 by 1/2. So, how many times does 1/2 go into 3/4? Well, we don't have to use the picture, but let's just do it for fun. How many halves can I fit into 3/4? Well, here's a half right here, and here's a half of a half. So it looks as though 1/2 divides into 3/4 1.5 times, 1.5. 1.5, also known as 3/2. Does that kind of make sense intuitively? So now let's do it with numbers. Again, there are various ways to do this, but I like just doing the same thing over and over again. I'm going to multiply by a handy form of 1. And I could do that in various ways. I'm just going to multiply the denominator by 2 and the top by 2. 2 over 2, that equals 1. The reason I did that is because I know 1/2 times 2 is going to equal 1. So that whole denominator becomes a 1. So now I'm just left with 3/4 times 2. If you want, you can put that whole number over a 1 so that we can remember, multiply the numerators together, multiply the denominators together. 6/4. Wait, is that 3/2? It sure is. I can do the same thing I just did before. Let's multiply the top by a half and the bottom by a half. Multiplying by 1 again, 3/2, sure. So when you're dividing fractions like this, you can just multiply by a handy number that gets rid of one of your denominators. Hey, could I have instead have just multiplied the top and the bottom by 4? Would that have worked? Let's try it. So let's multiply the top by 4 and the bottom by 4. I'm multiplying by 4 over 4 now. What's 3/4 times 4? Well, that gives me a 3. What's 1/2 times 4? Oh, that gives me a 2. Oh, I get the same answer, 3/2. So this whole multiplying by a handy form of 1 is really very handy. All right, how do we feel so far? Should we do some more? Let's do it. So often when folks are multiplying, I don't know, let's just make up something. This is what I see my students do a lot, and it's totally fine. 3 times 5 is 15. 10 times 7 is 70. Okay? And then they think, okay, what goes into 15 that also goes into 70 so that I can simplify? Oh, 5 goes into both. So 5 goes into 15 3 times, and 5 goes into that, let's see, once, 2, 14 times. And there is your simplified fraction. Okay? Totally correct, totally fine. But why do all that work? Remember, multiplication and division are two sides of the same coin. So I'm multiplying together my numerators, I'm multiplying together my denominators. Before I multiply them together, can I divide first? I mean, you divided out of 3, really, you divided out of 5 from the top and the bottom, or multiplied the top by 1/5 and the bottom by 1/5, right? Can I just do that here? Sure. Oh, look, there's a 5. 5 goes into itself once. 5 goes into that 2 times. 3 times 1 is 3. 2 times 7 is 14. Isn't that easier? So whenever I'm multiplying fractions, before I just willy-nilly multiply the numerators and multiply the denominators, I look to see if I can divide things before I multiply them together. Just makes your arithmetic easier. And so, for example, if I had, I don't know, 2/10 times 11, I don't know, 15ths, right? Oh, look, I can simplify that. 2 goes into itself once, 2 goes into 10 5 times, and then that's going to make my math a little easier. I still have to do a little arithmetic over here, not a big deal. So you're just dividing before you multiply. Okie dokie. Now, dealing with equations that have fractions. If I had something like this, I don't know, right? And I'm solving for x. Is it correct to divide both sides by 2/3? Absolutely. Absolutely. But then you have a fraction within a fraction, and that's awkward. So what would be the quickest way to solve this? Yeah, multiply by the reciprocal. This is just a friendly reminder. Multiply by the reciprocal. 3/2 times 2/3 is 1. Hey, let's use our new little trick here. I could say that's 24 over 2, but let's just divide before we multiply. Let's see, 2 goes into itself once, 2 goes into 8 4 times. That's 12. Not too bad. What if I had a fraction, what if I had a function that just had fractions all over the place and was just incredibly annoying? Yikes. I mean, it's not that horrible. Get rid of your fraction. How can I get rid of all these fractions? Come up with a number that you could multiply everything by. Now, in this case, I'm not multiplying a fraction, the bottom and the top by the same thing. Now that I have an equation, just like the last equation, I'm multiplying both sides by the same thing. So I could multiply every term on this side by 6. I could multiply every term on that side by 6. And presto bango, all of these denominators disappear. 6 times 1/6 is 1. 6 times x, 6x. 5/6 times 6, that's 5. And then my algebra is so much easier. Whenever you have a denominator in an equation, multiply both sides by that denominator to clear that denominator. Whenever you have a fraction in a fraction, you can multiply the bottom and the top by that denominator to clear it. Okay? Whenever you have a fraction that's in your way, you can usually rewrite it so that you have a whole number that's a little easier to deal with. I hope that was somewhat helpful. Have fun.